So this is a short video to overview some of the key points for Chemistry 2 on the AQA syllabus. So I've got some of the specification points here that I'm quickly going to go through. So one of the things you need to be able to do is to write a formula for ionic compounds from given symbols and ionic charges. So let me just show you something from the bite-sized website that actually goes through this. So if you go to, if you just search that term in Google, or bring up this as one of the first websites, you'll be given a data sheet in the exam, which has the names of ions and their formula with the symbol over here, and you can see the ones that are positive here under this, the positive ions, and the ones that are negative here, and the negative ions. Now, when it comes to the formula, the overall charge has to end up being 0. So you can see that these ones are positive, so they've got to cancel out with the negative charge to be negative overall. So you've got an example here of sodium chloride, so that contains Na and Cl. So if you look at Na is positive and Cl is negative. So there's one positive charge and one negative charge, so it ends up being NaCl. Okay, so the one positive from Na and the one negative from Cl cancels out. Magnesium oxide, or that's magnesium is +2, and oxygen, or the oxide ion, is -2 or 2-. Okay, therefore those 2's cancel each other out, so therefore you need one of each. You need one Mg and one O. You can see that there. Sodium oxide, however, is has one positive on the sodium, as we know from before, and has 2 negatives on the oxide ion, as we know from before as well. Therefore, you will need two Nas to cancel out with the one oxygen. And the final one, just final example to go through, copper nitrate. Okay, so it's got copper, which is 2+. You've got the nitrate ion, which is -. Okay, so therefore you need 2 of these nitrate ions to cancel out with one of the copper ions. Okay, so therefore the formula ends up being like this. Look carefully. You need 2 of the nitrate ion parts of it, so therefore the nitrate ion is bracketed off, and that's the bit that's got the subscript 2. Okay, remember the superscript, the bit written at the top, that's the charge. The subscript is a number of that many ions that we actually have. All right, so getting back to the PowerPoint. You need to be able to represent the electronic structure of ions in sodium chloride, magnesium oxide, and calcium chloride in the following form. So here's a sodium Na ion. Okay, so make sure you know how to do the structure of each of those, which was just mentioned on the previous slide. So the ion, remember, it's going to have a full outer shell. So if it's got one extra electron in there, remember, it's going to lose that extra electron. If it had 7 electrons beforehand, it's going to gain an extra electron to get a full outer shell. Okay, so represent covalent bonds in molecules such as water, ammonia, hydrogen chloride, methane, and oxygen. So you need to know covalent bonds in each of those, and also in giant structures such as diamond, silicon dioxide, and in the following forms. So here's one way to represent covalent bonds. You can see that they're sharing electrons here. Okay, there's one electron from the hydrogen in there, and one electron from the hydrogen in there, and an electron from the nitrogen as well. Or you could draw them like this, okay, where you can see there's dots and crosses that represent them coming from different particles. So you can see, again, the crosses are coming from the nitrogen, and the dots are coming from the hydrogens there. And in this one over here, you can see the bonds as straight lines. So you need to understand that each of these are different ways of representing covalent bonds. Also, remember in metals, bonding in metals is represented like this, or like this, okay, where you've got delocalized electrons either here in this form, or you could draw them in this form as well. Right, so a couple of key points now about some of these compounds. So remember, compounds are substances in which atoms of 2 or more elements are chemically combined. Chemical bonding involves either transferring of electrons in the highest energy levels, that's the shells are on the outside, in order to achieve electronic structure of a noble gas. Okay, so either transferring or sharing of electrons. So remember, transferring electrons is ionic bonding, and sharing of electrons is covalent bonding. So they're the 2 types of bonding that they've stated within there. When atoms form chemical bonds by transferring electrons, they form ions. So remember, if they're losing an electron, they become positive. If they gain an electron, they become negative. Ions have the electronic structure of a noble gas. So in other words, they have no electrons in the outer shell. This is what they're saying over here. They achieve the electronic structure of a noble gas. The point is, bonding is supposed to get you to a point where you have no electrons in the outer shell, therefore you're stable. The elements in group 1 of the periodic table, the alkali metals, all react with non-metals to form ionic compounds. in which the metal ion has a single positive charge. So all of the elements in group 1 of the periodic table, they are alkali metals, and they always react with non-metals ionically, okay, and they all have a charge of just a positive, okay, not positive 1, remember, just positive is the way you put that. The elements in group 7 are the halogens, and they all react with alkali metals to form ionic compounds. So they're the two groups that react together, group 1 and group 7, in which the halide ions have a single negative charge. So while these have a single positive charge, these have a single negative charge. Okay, they're going to gain that extra electron, they're going to lose their extra electron. An ionic compound is a giant structure of ions. Ionic compounds are held together by strong electrostatic forces. That's key. Okay, ionic compounds have strong electrostatic forces. Okay, these electrostatic forces are of attraction between oppositely charged ions. Remember, a positive charge is attracted to a negative charge, and a negative charge is attracted to a positive charge. These forces act in all directions in the lattice, so that's the structure that they make. Okay, and this is called ionic bonding. When atoms share pairs of electrons, they form covalent bonds. So we've just talked about transferring electrons to make ions. This is now talking about sharing them. These bonds between atoms are strong. Some covalent bonded substances consist of simple molecules such as H2, Cl2, O2, HCl, H2O, NH3, and CH4. So you've got methane, ammonia, water, hydrochloric acid in there. So you've got a few things that you're aware of. Others have giant covalent structures, such as macromolecules. So that's things on a large scale. So these molecules are small molecules. They're simple molecules. Giant molecules are macromolecules. So they build upon each other. The best examples of these to know are diamond and silicon dioxide. Okay. Metals have a giant structure of atoms that arrange in a regular pattern. So going back to this picture over here, that's the structure within a metal. The electrons in the highest occupied energy level, so in other words, that's the outer shell of metals, are delocalized. Okay, so these are free to move through the whole structure of the metal. Okay, so this corresponds to the structure of positive ions with electrons between the ions, hold them together by strong electrostatic forces. So these electrons around the outside, okay, they're free to move. That's why metals make good conductors, because those electrons, when given energy, are free to move throughout the metal, and therefore can conduct electricity well. Right, so we'll stop the video there, and I'll make another video on properties that I'll upload after this one.